I'm going to kick this next training off with a fun little riddle, and it goes a little something like this. It brings light to a dark world, in a current it travels, and through tunnels it's hurled. Touch it, and it'll kill you. What is it? Well, if you've already seen the title of this training, it's not going to be a tough guess. The answer, of course, is electricity. During this training, I'm not going to go super deep into the NFPA 70E standards that talks about the many hazards and safe work practices when working around electricity. But rather, my goal for this training is to ensure you have a very clear understanding of some of the most common electrical hazards that, though common, continue to pose some serious concerns as it relates to injury and death. The likelihood is that within your team, you have employees that are exposed to some very serious electrical hazards. I'll be sure to frame this training in such a way that everyone from your group all the way to the office leaves this training with a healthy fear and respect for this deadly hazard. So without further ado, please sit back and enjoy some education on electricity and the number of things you can do to protect yourself from this real, living, and predatory hazard. It's important as we start this training that you take a brief moment to stop, look around, and think about the countless number of products, appliances, and devices we rely on electricity for. In many ways, we are a culture that has taken this tamed beast for granted because of the various codes and regulations that have protected us both at home and at work. All of those standards and protections are awesome and have saved thousands of lives over the years, but these hazards are still very much a factor for you, whether you're at home or at work. In fact, electricity is such a huge part of our everyday, it would be foolish to never go through even a basic training such as this to ensure you're doing everything possible to protect yourself, your teammates, and your families. Even with a number of rules and regulations built to help us stay safe, in the U.S. workplace alone, there is one electrocution death each and every day. This includes experienced construction workers, linesmen, engineers, and manufacturers, and even office personnel. So please understand, this training absolutely applies to you. But as we think about the stats a little bit more, I want you to think through what I just said. There is one person today and tomorrow and the next day that will get up just like you and I did, will put on their clothes, go grab some coffee, tell their spouse and kids, love you, have a great day, see you later, but not return home because of this beast you're learning about, that when unleashed is seeking to devour anyone it has the chance to touch. Someone right now in this great country we live in is having to hear that their husband or wife, son or daughter is not coming home. Right now, there's a family grieving because they fully expected today to just be like any other day and see their loved one return home from work. It's a hard reality to swallow, and I encourage you to think about these families and keep them in your thoughts and prayers today as you watch this video. But back to the training at hand. If you listen to these basic principles and apply this training, your success as it relates to electrical hazards go way up. But stats and stories aside, you need to understand some basics on what it is and how it operates. If you can grasp the basics, you'll respect them. If you respect them, you'll respect the even more hazardous exposures your jobs can require, especially those in the shop or field. Now, in the next section, I'm going to break down the basics of electricity and what you need to know. When we talk about electricity, one of the closest similarities you can use to describe its characteristics is running water. Unleashing electricity is very similar to turning on a water faucet. Behind the faucet, there must be a source of water, and that water needs something to transport it and a force to make it flow. In the case of water, the source is a reservoir or pumping station, and it's transported through pipes. The pump is what provides the force, which then causes it to flow. For electricity, the source is the power box. The electrical current travels through electric conductors or wires, and the force, or in this case, the voltage, which is measured in volts and is provided by some sort of generator. It's somewhere in the breakdown or misuse of this process where shocks and electrocutions occur. This could be from a power source that holds an abundance of electricity, such as a power line, broken or damaged equipment that isn't properly taming the electricity, improper wiring, overloading a circuit with too much electricity where the current can't be properly contained, or very simply, unsafe work practices. That being said, in the next section, we will discuss how shocks happen and how electricity interacts with the human body. It's important you understand what this breakdown looks like and how it directly affects you when you continue working around unsafe electrical hazards. The following is the process by which shock occurs. The shock is received when the electrical current passes through the body, and then the severity of the shock depends on three things. Number one, the path of current through the body. Now please realize that even a small current that passes through the trunk of the body into the heart and lungs is capable of causing severe injury or death. You never know what the path of the electricity will take. Number two, the amount of current flowing through the body. And number three, the length of time the body is in contact with the circuit. Obviously, the more electricity, the harder it is to pull away from the circuit because your body will tense up so much you can't let go. Therefore, extending that length of time your body's in contact with the circuit. Yes, that's a horrible scenario. And please remember, there are plenty of items, tools, and equipment that have high voltage, but also high amperage. Many people assume that the electrical voltage is what injures or kills a person, when in fact, it's the amperage that injures and kills. Amperage is the amount of current flowing through an item. It is determined by voltage and resistance. When voltage goes up, amperage goes up. When protective resistance goes up, amperage goes down. The human body has a certain amount of natural resistance, but resistance can be increased by wearing insulated gloves and boots, and also by using insulated tools. Understanding the realities of amperage and the tiny amount needed to kill or injure an individual is important. So let me put it in a very simple term regarding the amount of amps it takes to injure and kill. And compare that with the average amps in regular items we use every day. Let's just start with a toaster. The average toaster uses about 9 amps. The average hair dryer uses about 10 amps. Keeping these two small items at the forefront of your mind, I want you to hear this next section very clearly. Even 1 milliamp, or 1/1000th of an amp. How many amps in a toaster? 9 full amps. 1/1000th of an amp can be felt by the human body. 2 to 10 milliamps can result in a minor shock. At just 15 to 20 milliamps, a person may lose muscle control and may not be able to release or let go of the circuit. This situation is especially dangerous if there are no other teammates in the area that can break them free from that circuit. But also please remember, never touch a person that is being shocked. Use a piece of non-conducting wood to pry them away from the electrical current if possible. Now, at 25 to 75 milliamps, the shock is painful and may lead to collapse or even death. The longer the person is exposed to this electrical current, the more likely death will occur. At 75 to 300 milliamps, for even a quarter of a second, is almost immediately fatal. Death is often the result of ventricular fibrillation, otherwise known as twitching heart, which occurs because the natural electrical patterns of the heart are disrupted. People often forget that our hearts are actively using specifically timed electrical pulses to maintain a healthy rhythm. Depending on the path the electrical current takes in your body, that electrical rhythm gets messed up and therefore the heart attack. So again, do you still have that 9 and 10 amp toaster and hair dryer in your mind? In the deadly numbers we discussed, did we ever get close to even 1 full amp before death was a very real possibility? No, we didn't. So please remember this when dealing with various tools, equipment, and even regular office equipment as well. There are 5 types of injuries that need to be addressed when we discuss electrical safety. The first is electrocution, which is the obvious one that most think about. When we use the term electrocution, please realize this doesn't just mean a shock. This means death caused by an electric shock. The second is electrical shock, and we talked about this just a bit ago when discussing amperage and its impact on the body. The third and often forgotten injury is electrical burn. Though it's often forgotten by those that have never been affected by it, it is the most common shock-related non-fatal injury. It typically occurs when you touch electrical wiring or equipment that isn't properly used or maintained, and most of these burn injuries are found on the hands for obvious reasons. Burns are serious injuries that need immediate attention. Like any burn, the protective layers of the skin are gone, and the infection can set in very quickly. Over 2,000 people are admitted into burn centers each year with severe electrical burns. That's an average of 5 to 6 people going to the hospital every single day for severe burns caused by electricity. The fourth is an arc flash burn. These are often fatal burns that can occur at distances over 10 feet when the electricity arcs. Be aware of arc flash warning signs near certain types of equipment and power boxes at your site or facility. Hearing loss can also result from the large sound blast that occurs from the boom of the arc. This is very similar to the thunderous sound lightning makes when it hits an object. Now, the fifth and final type of electrical injury is an indirect one, but still very real, and that's falls after being shocked. Workers in elevated locations who experience a shock can fall, resulting in serious injury or death. This happens far too often on work platforms and ladders. What could be a minor shock may result in a much more serious injury because of a fall. Be mindful of this, especially in seemingly harmless situations like changing a light bulb from a small ladder. So we've talked about all the many components of electricity, how shocks happen, the very minimal amount it takes to have an impact on your body, and a number of different hazards associated with electricity besides the shock itself. In this last section, I want to quickly run through some of the most common things you can implement to ensure you're keeping your teammates safe from these nasty hazards. They're as follows. First off, ensure certain electrical outlets, especially those around water, have a GFCI built into them. They can be identified by the test reset buttons on the plastic piece of the outlet that you often see in homes. If you don't know what a GFCI is, you're probably not alone, but it's a ground fault circuit interrupter, and it recognizes sudden changes in the flow of electricity and will shut off the circuit when spikes of electricity occur, so the electricity stops flowing. If the electricity is allowed to continue, it could result in serious shock or electrocution, and for that current we discussed earlier to continue flowing through your body. In the case of a fire hazard, without a GFCI, the items will continue to pull energy, which then in turn builds more heat and can therefore cause a fire, as in the case of overloaded circuits at Christmas time. This is also true of office staff who like to keep both an AC unit and heating unit under their desk because they don't know how they're going to feel that particular day. So do not overload circuits. Power strips have GFCIs built into them, and this is why they're a good option if multiple items are plugged into one outlet. But be sure they work and don't use just any power strip for high wattage items. The second recommendation is to not allow extension cords or any electrical equipment with cuts in them to exist in your workplace. This exposes the live wires and shocks may result. Using the analogy of the water we discussed earlier, I want you to think of a water hose that has a small cut. In the case of water, we actually get to see what's coming out of that cut, even if it's just a little drop of water. Now picture that hose as an electrical wire and that drop of water as electricity that's leaking out. Take care of the electrical wires as you would a cut hose. If you don't, you're allowing that electricity to flow freely and create a potentially deadly hazard. All right, third, have a strict lockout tagout policy that allows only trained employees to work on and provide even basic maintenance for tools and equipment. You do have a solid lockout tagout training on this platform, so check that out for more detail. Fourth, keep electrical shutoffs properly labeled and free from obstruction. They should always have a 36-inch diameter of free space with no objects blocking access to them. If an emergency happens, they could need to be shut off immediately. Fifth, maintain all tools and equipment that utilize electricity. Shocks can occur simply as a result of poorly maintained tools and equipment. If you notice any, notify a supervisor right away and don't attempt to fix it yourself. Sixth, circuit breaker boxes need to be labeled with the appropriate warnings and also need to be clearly labeled as to what each breaker is associated with. 7. Overhead power lines on construction sites must be labeled and assessed pre-job for arc flash hazards. Electricity from a power line can easily jump more than 10 feet. Like I said earlier, This stuff is very much like a wild animal looking for someone to pounce on. Electricity never sleeps and is always looking to find a path to ground. And lastly, be sure you're being provided the proper personal protective equipment in designated areas. The more resistance you create for the electricity, the less current can flow through that source and into you. In conclusion, I want you to think about those individuals that will die and those that will experience horrific burns all this week. I don't say that to scare you, but I certainly say that to wake you up and bring it as close to home as possible to ensure you're living these safe principles around electricity, both at home and at work. Promise me that you'll take them to heart and have some intentional conversations with your teammates about ways you all can improve your operations. And with that, I'll see you in the next training.